In this lesson, we'll talk about solving linear systems by graphing by hand. A linear system can be solved by graphing. And the way we do that is we graph the equations on the same Cartesian plane. And then the pointer points of intersection of the lines represent the solution to the system of equations. So we're looking for a point of intersection when we want to solve a system of equations. Now, with a hand-drawn graph, we may not be able to find the exact solution to a linear system, and this is particularly true if the point of intersection doesn't fall on one of the grid lines of the paper. So in other words, what this means is we're going to get an approximate solution, but if our graphing isn't perfectly accurate, and that is often the case even when we try our best, then the solution that we get might not be perfectly accurate as well. So the first question is, we'll determine the solution or solutions, if any, of this system of equations. We've got two equations, and we're going to do this finding the solution by graphing. So we're going to use a table of values. For y equals x plus 5, if we let x equal -1, y is 4. If x is 0, y is 5, and if x is 1, y is 6. And if y equals 3x plus 7, then if x is -1, y is 4. If x is 0, y is 7, and if x is 1, y is 10. So what we'll do next is graph these points. So looking at the line y equals x plus 5, we graph the 3 points that we were given, and we draw a straight line, y equals x plus 5. And looking at the line y equals 3x plus 7, we graph the 3 points we were given, and we graph that line in red. And now what we do is we look for a point of intersection. Well, looking at these two lines, they may not be perfectly drawn, but it would appear that the point of intersection is probably at -1, 4. And so that's what we do. We say that the point of intersection is -1, 4, which means that the solution to the system is -1, 4. Okay, we see that the point of intersection is at -1, 4. Right? -1, 4. And therefore the solution to the system is -1, 4. Now, this is kind of a funny question, because actually if we were really keeping our eye open, we might have seen that just from the table of values. Both tables of values contain the point -1, 4. But, you know, that doesn't usually happen. So usually what we have to do is find it by getting the point of intersection off the graph. Alright, for this question, we're going to determine the solution or solutions, if any, of this system of equations. And we're going to do it by graphing. So we've got two equations, and we've got two variables. So we have a chance to find a solution. So we're going to use the Intercepts method to graph this. When I look at the line 4x minus 3y equals 5, I can find the x-intercept by letting y equal 0. Letting y equal 0, subbing in a y value of 0, gives us an x value of 5/4. So that means the x-intercept of the line is 5/4, 0. Now finding the y-intercept means letting x equal 0, subbing in an x value of 0, we get -3y equals 5, which means y is -5/3. And so we've got an x value of 0 and a y value of -5/3. And that's our second point. So we have 2 points on the line. And in a moment we're going to graph that line. But now we're going to find the x and y intercept of the second line. The second line has the equation 2x minus 6y plus 5 equals 0. Finding the x-intercept means letting y equal 0, which we do. And then we can solve for x. X is -5/2. So x is -5/2 and y is 0. Finding the y-intercept means letting x equal 0. And so we do that. We sub in an x value of 0, and we solve for y. And y is 5/6. So the second line has an x value, the second line has an x-intercept of -5/2, 0, and a y-intercept of 0, 5/6. So looking at the first line, 5/4, 0 is here, and 0, -5/3 is down here, and we draw a line through those points as far as we need to. The second one has an x-intercept of -5/2, 0, which is right about there, and a y-intercept of 0.5/6, which is right about there. And then we draw a straight line through those two as long as we need to get to our point of intersection. And now we see that our point of intersection isn't going to be very precise. It's going to be an approximation. And it looks like letting each one of these grid squares be half a unit, so letting one be 2 grid squares over, we see that our point of intersection appears to be approximately 3.7, 3.1. And so we say that the solution to the system of equations obtained by the graphing method is approximately 3.7, 3.1. Alright, for our next question, it's a word problem question. We're going to suppose that 5 chocolate bars and 8 gumdrops cost $34, and that 8 chocolate bars and 3 gumdrops cost $25. What we want to do is determine the cost of 1 chocolate bar and 1 gumdrop, and then we're going to check our answer algebraically. Well, here we can make one equation. 5 chocolate bars and 8 gumdrops are $34. And here we can make a second equation. 8 chocolate bars and 3 gumdrops cost $25. When we do that, we'll have 2 equations with 2 unknowns. So we're going to let x represent the price of a chocolate bar, and we're going to let y represent the price of a gumdrop. So 5 chocolate bars plus 8 gumdrops is $34. And 8 chocolate bars and 3 gumdrops is $25. We've got 2 equations, 2 unknowns. Using the Intercepts method, the equation 5x plus 8y equals 34, we get an x-intercept of 34/5, 0. We get a y-intercept by letting the x-coordinate be 0 and solving for y. We get a y-intercept of 0, 34/8. So we're going to graph a line with this x-intercept and this y-intercept. But we have to draw 2 lines, so we're going to have to find the x-intercept and y-intercept of the second line. The second line was 8x plus 3y equals 25. Well, finding the x-intercept means letting y equal 0. Letting y equal 0 and solving for x gives us an x value of 25/8. So we have 25/8, 0. And then we find a y-intercept by letting x equal 0. Plugging in an x value of 0 gives us a y value of 25/3. So for our second line, we have an x-intercept of 25/8 and a y-intercept of 25/3. So we're going to graph both of these lines. The red one with these 2 points, which is 5x plus 8y equals 34, and the black one with these 2 points, which is 8x plus 3y equals 25. Doing that, graphing our 2 x-intercepts and drawing our black line, graphing our x-intercept and y-intercept and graphing the black line, and then graphing our x-intercept and y-intercept and graphing the red line, we see that they seem to intersect at a point of 2, 3. Now you might ask yourself, well, what's the significance of the point 2, 3? Well, if you remember some time ago in the same solution, we said, let's let x represent the price of a chocolate bar. And we said let y represent the price of a gumdrop. Well, what that means is that x is 2, so the price of a chocolate bar is $2. Y is 3, so the price of a gumdrop is $3. And what we're saying is that both questions will be satisfied, both equations are satisfied, if x is 2, chocolate bar is $2, and y is 3, a gumdrop is $3. But we can check that algebraically. So we say the point of intersection is 2, 3, a chocolate bar is $2, and a gumdrop is $3. But let's check it algebraically. First of all, let's plug that into the equation 5x plus 8y equals 34. 5 times 2 plus 8 times 3 equals 34. That's a true statement. So if a chocolate bar is $2 and a gumdrop is $3, 5 chocolate bars and 8 gumdrops is $34. Secondly, we plug it into the second equation. 8 times 2 plus 3 times 3 is 25. Well, that means 16 plus 9 is 25. That's a true statement. So similarly, if a chocolate bar is $2 and a gumdrop is $3, that means 8 chocolate bars and 3 gumdrops would be $25. That's also true. Awesome. Okay. For our next question, we see that Ahmed starts his own lemonade stand, and the cost of starting up the business is $15. Each glass of lemonade costs Ahmed 50 cents in materials. He sells each glass for $1.25, and he wants to know how many glasses he'll need to break even. Well, in a context like this, breaking even means that his costs equal his revenue. In other words, the amount of money he spends is equal to the amount of money he receives. So we have to come up with an equation for the amount of money he spends and for an equation for the amount of money he receives. Well, the amount of money he spends is called cost. And so if we let X be the number of glasses of lemonade that he sells and we let Y be the cost, then we can see that Y is going to be 50 cents for every glass of lemonade he sells plus a $15 flat rate. Red line meaning this is the amount of money he's spending. His revenue, however, is $1.25 per glass. So in black, that's the amount of money that he's making. Here's his cost and here's his revenue. So if we graph both of these on the same line, on the same graph, sorry, we can do that using the table of values method. So the equation y equals 0.50x plus 15 can be graphed using a table of values. When x is 0, y is 15. When x is 10, 0.50 times 10 is 5 plus 15 is 20. When x is 20, 0.50 times 20 plus 10 plus 15, is 10 plus 15, which is 25. Following the same procedure over here, we come up with two different tables of values, and that allows us to draw two different lines. The red line represents Ahmed's cost. That's the amount of money that he's spending to stay in business. The black line represents Ahmed's revenue. That's the amount of money that he makes, the amount of money he brings in. Well, where does the revenue equal the cost? Well, it would appear that that occurs at the point 2025. Now, if you remember, we said X is the number of glasses and Y is the cost or the money involved. So when he sells 20 glasses of lemonade, the total cost is $25 and it's equal for both. And so that's what we write. 20, 25. X is 20 implies 20 glasses. Y is 25 implies $25. So in order to break even, he'll need to sell 20 glasses of lemonade.